Hey guys, just to let you know, this lesson is in collaboration with Flip Academy, a free online platform for all of your GCSE, A-level, IB and CBSE revision, out now on web at www.flip.academy, and also as an app for Apple, iOS and Android. It really is better than all the other GCSE platforms out there. It covers all the topics in great depth and has an app that you can download your courses on and use offline.
Hello everyone and welcome to Flip Academy. Today we're going to be doing the ratio, proportion and rates of change topic for AQA maths. So here again we've just got our spec points, so change between the standard units of length, area, volume and capacity. We actually went through this in the numbers section as well, so if you want to go back to that you can have a look. And you also have to have compound units. So for example here, the heel of a shoe exerts a pressure of 188 pounds per square inch, and we need to convert this into kilograms per square centimetre. So 1 pound is 0.45 kilograms, so to go this way we would times by 0.45, and if you want to go against it we divide by 0.45. Okay, so we want to go from pounds to kilograms, so we're going to times it by 0.45. And again, this is normally this is going to be on a calculator paper, so if we just bring up our calculators, we have 198 multiplied by 0.45. That leaves me with 89.1, and that's kg per square inch. And the last thing we need to do is convert square inches into square centimetres. So once again, it's going to be a multiply, but we have to be careful here. So when we're doing this pressure, we have pounds, and then per square inch, the square inch is at the bottom. So if we're timesing this by 6.25, what we're doing to the overall thing is actually dividing, because the bottom, the denominator, is getting 6.25 times bigger. So divided by 6.25. Okay, so remember anything that's on the bottom of the fraction. So actually let's write this out first. 5, 6, and that is kilograms per square centimetre. Okay, so anything that's on the bottom of a fraction is going to be divide, anything that's on the top is going to be times, if you're going the correct way about it. Next thing we have is scale factors and diagrams. So a map has a scale of 1 to 75,000, so what that means is for every 1 unit on the map, that's equal to 75,000 units in real life. So the distance between 2 points on the map is 12 centimetres. So here we have 1 to 75,000, and then on the map it's 12, so we have to work out what it's to here. So all we do is to get from 1 to 12, we're timesing by 12. So to get from 75,000 to the answer, we're going to also times by 12. Once again, it's going to be on a calculator paper. So 75,123 times 12 gives me 900,000 centimetres. Now it tells me to go from centimetres into kilometres. So centimetres to metres, we divide by 100. So that's going to give me, so a slice of 2 zeros, we have 9, 1, 2, 3, so 9,000 metres. And then to go to kilometres, we divide by a further 1,000. That gives me 9 kilometres. Nice and easy. The other type of scale diagram they can give you is that they give you an accurate scale drawing showing a small box and large box. Now, accurate means that you can measure and it would be correct. So using either a ruler, and it also works for angles as well, so protractors. So the angles and the sides are all the actual length and size that they appear to be on the diagram. So it tells me that the small box has a real height of 20 centimetres. So we need to find an estimate for the real height of the large box. The problem is we have no scale. So we need to work out what the scale is. Okay? Now I know that this box, the height in real life is 20 centimetres. So let's see what that represents on the diagram. So if we pull out our ruler and we're going to align it nice and neatly, so it should be 90 degrees. So you can see here it's 1 2, 3, 4, 5, 6. So this is actually, so 1 centimetre, 1.2, 4, 6, 8. So 1.8 centimetres is equal to 20 centimetres. Okay, so 1.8 centimetres on my diagram is 20 centimetres in real life. So if we divide both sides by 1.8, that will give us what 1 centimetre equals. So 20 divided by 1.8, again these are all calculator questions, and we get 100 over 9, so 11.1 recurring. And again, this is an estimate, so it's okay if you get a slightly different answer. Now what we're going to do is measure the height of the large box. So we're going to line this up nice and neatly, and we have so we have 1 centimetre, 2, 3, 4, 5, 6, 7, and then 8.4 centimetres. So if we want to get to 8.4 centimetres, again using our scale, we times this side by 8.4, which means we have to times the other side by 8.4. And again, they do give you a bit of a range, so it's not as bad. So again, answer times by 8.4, which gives us 93.3 centimetres to 3 sig fig. And again, it does look about 4 times bigger, 5 times bigger, so that is probably correct. So now we don't need this anymore. So, for the next part, we have to express a quantity as a fraction of another quantity. Okay, so quite simply, all we need to do is, for a lot of these things it can be quite easy, so I've picked a slightly trickier example. So Lily's age is 2 years and 4 months, Hugo's age is 1 year and 8 months, write Lily's age in months as a fraction of Hugo's age. So we're going to do Lily's age over Hugo's age, because it says write Lily's age as a fraction of. Okay, so we're just going to do Lily divided by Hugo. Now 2 years is 12 times 2 months plus 4, so that's 24 plus 4 is 28 months, and Hugo is 12 plus 8, so 20 months. So what we have here is 28 over 20. It says to give your answer in its simplest form, so we can divide the top and bottom by 2, and that gives us 14 over 5, which is the answer in its simplest form. Next is using ratio notation. So essentially, there aren't really any questions on this because every ratio question will have ratio notation. So all you need to realise is that ratio notation looks something like this. So it might say the number of red pens to blue is 5 to 4. And that's all it means by ratio notation. However, you should also know that you can simplify ratios. So yellow to green, let's say it's 6 to 4. So I can always ask myself, is there anything I can divide both of these numbers by? Do they have a common factor? And if I look, I can divide both sides by 2. Right? So I should know that that is completely equivalent to 3 to 2. These ratios are completely the same. Okay? So that's all it means in terms of ratio notation. So understanding, being able to recognize it, and then being able to simplify it, and that's all that spec point means. Okay? So it shouldn't be too bad. Now jumping right into dividing a quantity into a certain ratio. So, again, this is the 2021 paper 3. Jeff and Kaz share £270 in the ratio. Jeff to Kaz is 2.6 to 1. Okay, so Jeff gets £2.60 for every £1 Kaz gets. So normally I'll draw a little bar out and draw the little boxes and everything like that, but in this case it's going to be a bit tricky to do that because it's a decimal, so we're not going to draw boxes. Instead, we need to work out how much Kaz and Jeff get. Okay, so if we work out how much Kaz gets first, the best way to do this is to use fractions. Okay, so again, you can use like where you draw out a box and you shade them in and all that fun stuff. In this case, because we have a decimal, there's no point doing that. And what we're going to do is we take the number we're interested in. So with Kaz, we're looking at the number 1, and that's over 2.6 plus 1. And then all we need to do is multiply it by the total amount of money. So again, it's a calculator paper, it's paper 3, so let's do it. So we have 1 over 2.6 plus 1, and then multiply by, so if we just press equals, multiply that by 270. Kaz gets £75. Now again, what you could do is do 270 minus 75 to get your answer, but in this case I'm actually going to do the exact same thing for Jeff, just to illustrate my point. The number we're interested in now is 2.6 over 2.6 plus 1 times 270, and again you should get the answer of, actually no, let's do it the proper way. It should be 195, but let's do it. We have that bracket 2.6 over 2.6 plus 1, close bracket, multiplied by 270, 195. Okay, so of course you can still do, what might make sense, 270 minus 75. That's to illustrate my point. Now the actual question says, how much more than Kaz does Jeff get? So he gets 195 minus 75, 120 more than Kaz. Okay, so in terms of the marks, you get a mark for this, a mark for that, and then a mark for the final point. The next bit, again, is a relatively short topic. Express a multiplicative relationship between two quantities as a ratio or a fraction. So, again, November 2021 papers, A is half of B, right? So in other words, B is 2 times A. Okay. Now, if B is 2 times A, then that is the same as writing a ratio of B to A as 2 to 1. So if you were to write this A to B, all you do is flip it round, it's 1 to 2. So the answer would be this one, okay? So if one quantity is twice another, it's in a ratio of 2 to 1. If it's 3 times another, it's 3 to 1, and so on. Okay? The next bit is understanding and using proportion as equality of ratios. So it's very similar to the previous part, right? So the idea is that if I say that B is 3 times bigger or more than A, hopefully you can see that that's proportion, right? B is 3 times A, then B to A will equal 3 to 1. That's what it means by equality of ratios, the fact that those two things are equal. They mean the same thing. Okay? Likewise, if you're talking about proportion, if you're saying that to bake 10 cookies, you need 2 eggs, they can ask you, well, what if I want to bake 20 cookies? Well, then hopefully you can see that you'd need twice as many eggs, because to go from here to here you times by 2. So the number of eggs you need should also double. And that's all that means, okay? So this is kind of proportion, and then proportion and equality of ratios, just meaning that you should note that proportion and ratios are the exact same thing, okay? That's all it means. Next things, we need to relate ratios to fractions and to linear functions. So again, similar to what we've done before, if I have so let's say I'm splitting money, or splitting 24 sweets, between Bradley and Stephen, and the ratio of Bradley to Stephen is 3 to 1, I should recognise that this means that Bradley gets 3 over 3 plus 1, so 3/4 of the sweets. Okay? So a lot of these spec points are about notation. So being able to understand what we mean by ratios and linking them to fractions and things like that. Okay? So it's not necessarily there's a lot to remember, it's just that there's a lot that you have to really process and really understand, okay? So that's all that means here, is that ratios are the same as fractions. Likewise, if I say that in a different universe, Stephen gets 2/3 of the sweets, you should be able to change that into a ratio of Bradley to Stephen. Well, Stephen, he gets 2 parts because it's the number on top. And then 2 plus something gives me 3, it's 1. So that's the ratio they share in that universe, okay? So you need to be really, really aware of that, okay? You should be able to go from fractions to ratios in the way that I've just described, and from ratios into fractions, again, in the way I've just described. Hopefully that all is completely fine. The next part is all about percentages. Okay, so there's a lot of stuff you need to remember for percentages. And again, we do have a couple of examples here, but we need to go through some basics first. So first of all, a percentage is just a number of parts per 100, okay? So the idea is that 30% is the same as saying 30 parts per 100. This doesn't really come up in questions at all, but the idea is that you should be able to say that 30% is the same as 30 over 100. Okay? Likewise, 21% is the same as 21 over 100. You need to be able to link percentages to fractions of 100 and the fact that it is just kind of always out of 100. Okay? You should also be able to interpret percentages, so again 21% as 21 over 100. You should be able to also write them as fractions, but also decimals. Okay? So 21 divided by 100, hopefully you know, if you have 21 divided by 100, you're just moving the decimal place twice, which means it's the same as having 0.21. Likewise, if you have 30, just add a decimal point and a few zeros. If you're dividing by 100, you take the decimal point and you move it to the left twice, you get 0.3. Okay? So you should be able to change between percentages, fractions, and decimals. Again, it's really easy to go from percentage to decimals. You just divide by 100, which is just moving the decimal point twice to the left. Likewise, going from decimals to percentages, you just move it twice to the right. So 0.21 is just 21, 0.3 is just 30, and so on. You should also be able to interpret these multiplicatively. So what that means is if I say 21% of 200, that's the same as doing 21% times 200. So the best way to write that is as a decimal, so 0.21 times up 200, and then working out what that is. Okay? So, and again, you should be able to do that as a fraction or as a decimal, right? So all of these things are the same. You need to interpret that fractions, decimals, and percentages are just multiplying. Okay? And they'll all give you the same answer. Okay, so now that's a bit obscure, so let's get on to some hardcore maths. The next thing you need to be able to do is to work with percentages greater than 100. Okay, this is a really key thing, okay? In general, if something is a 3% increase, that is the same as saying it's at 103% of the original amount. Okay? That's all that means. 3% increase, so it's at 103. So all I did to do that, to get that, is 100% is its original price, right? Then I add on the 3% that it's increased by. Okay? So in this case, David is getting paid £34,000 per year. He's going to get a 3% increase in the amount of money he's paid. So you can either do the thing where you find 3% and then you add it on, or you can say £34,000 and I'm timesing that by 100 plus 3%. So it's the same as just doing 103% of 34,000. Okay, now in terms of different ways you can do this, one way which I'm quite partial to is changing that to a decimal. So remember, to change to a decimal, you move it to the left twice and you just multiply it. Nice and easy. So again, it's all calculator stuff, so it's not too bad. 1.03 multiplied by 34,000. £35,020. And again, this is my preferred method of doing it. Or again, you can leave it as a percentage, so 103% of... so you can do it where you literally times by 103%. The percentage sign is just shift and the ANS button, and that gives you the same thing. Okay. Likewise, if you wanted to do it as a fraction, right, you have 103 out of 100 multiplied by 34,000. Again, you get the same thing. So it doesn't matter if you use a decimal, a percentage, or a fraction. It's all the same thing, which is exactly what we just said. Okay. The next thing that you have to do is also calculate percentage loss and percentage profit, right? So I really like percentage profit and loss because there's one formula, okay? It's the final amount minus the original over the original, and this works every single time, okay? So with this final amount, it was £213,590 minus the original price of £201,500. We're dividing it by the original, so 201,500. Then multiplying it by 100. So again, let's whip out our calculators. So we have that, and then fraction button. We have 213,590 minus 201,500 over 201,500 multiplied by 100 gives me an answer of 6. So in other words, she made a 6% profit. That's it. Now there are a few different ways to do that. Okay, a few different ways. So some people teach you just to do final over original times 100, but then you need to minus 100 as well. That's why it's too complicated. For loss, some people teach you to like reverse this to original minus final. You can do that, but look what happens if we use our exact same formula. We take the final minus the original. The final was £325,600. Take away the original. Over 352,000 times 100, okay? So look what happens when we do the exact same thing. So we're using the same formula, okay? So some people teach you a different formula, but there's really no need for it at all. This is way, 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 way easier because you're remembering fewer things. You get a negative number. So this is where people panic, and that's why they want another formula. But let's think about it for 1 second, right? She's lost money, right? That's where the negative comes from, right? The word loss is the negative. So this translates to a 7.5% loss. For those of you that use a different formula, do the exact same question but use your other formula, you get the same answer. Okay? So best thing to do is if they ask you how to work out percentage profit or loss, use the same formula. If it's a positive number, it's profit because her money is 6% more. If it's a negative number, it's a loss because she's lost 7.5% of her money. Makes sense, right? There's no point in remembering multiple formulas, in my opinion. Okay, but you need to be able to do both of those, whichever way makes you comfortable. The last thing is you need to be able to apply percentages for more than 1 year. So that sounds really complicated. All it means is interest or depreciation. So Perry invests £25,000 for 3 years in a savings account, and she gets 2.7% compound interest. So what that means is her money increases by 2.7%. So again, if we use our little thing, that's 100 plus 2.7% her money is increasing as. So that's 102.7%. That's how her money is increasing every year. Okay? To write that as a decimal, let's move the decimal point 2 spaces over to the left. That's 1.027 each year. Okay. Now here's an interesting thing, right? To work out the amount she has at the end, okay, we take our £25,000, we times it by this little multiplier we have. Right? Now that only works for 1 year. So if I want to write this again, the next year you'd times it again. And for the third year you'd times it once again. So instead of writing that, because that's a bit long and tedious, get rid of it. All you need to do is put brackets and put it to the number of years. So if you want a kind of formula, the final amount equals the initial amount times your multiplier to the power of the number of years you're investing, or the number of years past, whatever you want to call it, right? Simple as. So again, a lot of students find compound interest difficult, but once you really understand where it comes from, it's really not that bad. And that's a common theme with GCSE maths. It's difficult until you understand it. So you need to accelerate the understanding. So 27,000, so let's think for a second. There's a lot of decimal points. What should I round it to? Well, it's money, right? So we should only round to 2 decimal places, right? You don't have 0.16708 of a pound. So, £27,000, £27,080 and 17 pence. Not too bad. And that's everything you need to know about percentages, okay? You need to take percentages of numbers, you need to do percentage loss and gain, profit, and compound interest as well. Okay. Time for some proportionality. I'm quite partial to proportionality, it's quite fun. This is part A, this is part B. So, L is directly proportional to D squared. That means as D goes up, D squared goes up, L also goes up. So, work out an equation connecting L and D. Well, what we do is you put the L, and directly proportional is this symbol. Okay? So if it said L is equal to D squared, then we'll put the equal sign. But because this is directly proportional, we put the proportional sign, which looks like an alpha from science, or just like a fish with a bit of a tail missing, going the other way. Now to get rid of that sign, we need to introduce a constant. And that's how we get rid of that sign. So L is not equal to D squared, it's equal to something times D squared. Now, some students leave it here. This gives you 1 mark. It's a 3-mark question. It's not going to be 1 step. Okay? They also give you this information. They never give you information you don't need. Okay? So, we need to work out what K is. Now, K will be L over D squared, which is 85 over 10 squared, so that's 85 over 100, so it's 0.85. Just in case you don't believe me. .85. Cool. So I'm not done yet. That's the 2nd mark. The actual answer is L is equal to 0.85 D squared. Hopefully that's not too bad. So, for part B, it's nice and easy. Find out the value of L when D is 5. Well, L is equal to 0.85 5 squared. Shove it in a calculator. So answer times 25 is 21.25. That's 2 marks, doing about 5 seconds. Not too bad, I'd say. So again, that was from paper 2. 2020 paper 1 also had this. Now this is a fun one. Okay. It is inversely proportional to, not directly proportional. So what that looks like is 1 over whatever is on this side, okay? So, directly proportional, L, proportional sign, D squared. Inversely proportional, it's M, 1 over square root of R. It then asks us, the value of r is multiplied by 4. So I don't need to do anything else, by the way. So if I did m equals, again, you multiply both sides by r, by k. It says r is multiplied by 4. So if this became 4, right? So if I multiplied that by 4, what would happen to the value of m? Well, let's have a look. The square root of 4 is equal to 2. So now m will equal k over 2. So the value will divide by 2. Hopefully that's not too bad. Compound units. Okay. So the compound units that you need to know, the main ones are speed. And if you remember, that's distance over time. So you have to use all different distances over all units of time. So I'll show you some common ones, but keep in mind they can't ask you about some others. You have meters per second, you have kilometers per hour, you also have miles per hour. You need to be able to use those units and convert between them. You have rates of pay, which is always just going to be basically pounds per hour or pounds per week or day or whatever. You also have density, which again is mass over volume. So it's usually going to be kilograms per cubic meter or grams per cubic centimeter. And lastly, we have pressure, which is force over area. That is 9 times out of 10 given as newtons per square meter, but it can also be given as pascals. Or, as we had before, you have PSI, which is pounds per square inch. Those are the main ones. You just need to be able to use them, okay? So what that means is when you do a calculation with density, you should be able to say what the units are. And if you do a calculation with speed, you should be able to say what the units are, and so on, which I'm hoping you're completely fine with. Next one is comparing lengths, areas and volumes using ratios. So again, we have the 2021 paper 3, which you've looked at a few times. So, in general, what you want to do is, if it's just a length of some kind, right, what you're going to do is square root area or cube root volume. Likewise, if you want to find the area, you're going to just take the length and square it, and if you have volume, you're going to take the length and cube it, okay? So in this question, our length is our ratio. So we're going from an area to a radius. So all we're going to do is just square root it. So square root of 2, and then for B, we have the square root of 4.5. So our answer is the radius of cone A to cone B is going to be root 2 to root 4.5. However, it's asking me to put it in as 1 to another number. So to do that, we divide by square root 2. So we need to divide this side by square root 2. And again, it's fairly simple. Actually, let's just quickly do this. So we have the square root of 4.5 divided by the square root of 2. 3 over 2. So we don't normally write fractions, so let's do 1 to 1.5, okay? So again, it's a lot of students find it tricky, but it's not tricky. It's just because they haven't covered it before, okay? So if you want to get a length, which you always do in these questions, you either square root whatever the area is, or square root the volume, okay? And that will give you your answer. You can also find the ratio between them and then square root it, but either way, that's what you're going to be doing. This question, it's really a bit obscure, but it's not that bad. So essentially all it's saying is that you should know that if you say x is inversely proportional to y, that gives you this, right? So again, x That is the exact same as saying x is directly proportional to 1 over y. That's it. That's all that matters, okay? And you need to be able to construct equations from that. So if they tell you x is directly proportional to this, then you need to do what we did in the previous part up here and create an equation. But you should see that, so sometimes they may have a multiple choice question, say which two are equivalent. These two statements here would be equivalent. We're going to get onto some, again, obscure stuff. You need to be able to interpret the gradient of a straight line as a rate of change. So the idea here is if you have a straight line graph, and let's say this is a cost in pounds, and this is the amount of time, the gradient is going to give you cost per time, right? And specifically, it's going to give you a rate of change. So how quickly cost changes with time. And the steeper it is, so the steeper it is, the faster cost changes with time. So if you want a generic thing, is the gradient is going to give y per unit x. Okay, that's all you have to say. You say whatever's on the y-axis per unit whatever's on the x-axis. In this case, it's cost per unit time. If this was a volume and time, you'd say it's the volume per unit time. Okay, super easy, and it will always give you a mark. And it will also tell you, if they ask you to, again, that's how you interpret it, right? It's the y-axis per unit x-axis, or how quickly y changes with x. Okay? So in any of these questions, if it asks you, if it ever asks you, interpret the gradient. What does the gradient mean? Always just say it's whatever's on the y-axis per unit whatever's on the x-axis. You will always get the mark, nice and easy, and you'll be able to get that. Now, if you're doing the higher tier, this is where things get a bit more interesting, okay? Because what if you have a curve, okay? So let's say you have something like that. Well, the gradient of, let's say, a point here is, the only difference is that it's the instantaneous rate of change. So what it is, it's the y per unit x at that value of x. And only that value of x. Okay? And again, also, one thing you may want to remember is that if it's a distance time graph, what does it mean for it to be distance per unit time? That is your speed. Okay? So that's just one other thing to remember. Okay, now the last spec point says to set up, solve and interpret the answers in growth and decay problems, including compound interest. And also, something they don't mention is depreciation. And if it's higher tier, it's also going to be iterative processes. This question here is all of those in one. Okay? It's a growth problem, which is very similar to compound interest, and it's an iterative process. Okay? So assume that the population increases by 12% each day. Okay, so increase by 12%. So once again, we have 100 plus 12%, which is 112%. Cool? Now if you remember, I said that final is just equal to initial times your percentage but as a decimal, so that's 1.12. To the power of the number of years or days. In this case it's days, it really doesn't make a difference. This is going to be a very big number, I'm very, very sure. So we have 4,200 multiplied by, open bracket, 1.12 to the power of 20. Yep. And I'm not going to write the decimal because it's the number of butterflies. And, you know, I don't know much about butterflies, but I'm pretty sure you can't have 0.4 of a butterfly. So we'll leave it as that, which is indeed greater than 40,000. So what does it mean by iterative process? Well, an iterative process is just where you do it day by day. So you'd find out what 1 day is, then you find out 2 days, and so on. That's it. I know it doesn't really seem like a higher topic, but it's not too bad. Anyways, that is the end of the ratio topic, so slightly shorter than an Algebra 1, so hopefully you found it a bit less taxing on the mind. But yeah, I hope you enjoyed, and I'll see you in the next one.